Super. So we'll start, and rest of the team will join while we are, conducting the class. So I have watched the first day class video, and I'm Chatura Bandara. Again, a little intro. So I'll be conducting today's class, and also like Darshan mentioned last week, we will be, doing these classes. Sometimes we'll be, connecting. We both are connecting for one same class, and also, some days we're doing like individual classes. So today we'll be starting our module 2, and without a further ado, I will, we will look into our agenda today. This is the content. So we have 10 elements, actually 10 agenda items. First, we will have a Kahoot, a game, small game. So we will to understand what we have learned last week, also to reflect the things. After the Kahoot, also we will reflect the last week content, just to brush up our knowledge. And then we will go into excellence definitions. In quality, we will be understanding the quality control, quality assurance, quality engineering, and quality management systems. So we will understand separate philosophies, and also we will identify the differences in between those philosophies. And also stages of inspection. Then we're going to learn waste observation, what is built-in quality as well today. So because this is built-in quality, so we need to understand what is this built-in quality, the definition, and the background behind it. And the sixth point, the highlighted, the bold highlighted point is to have an assignment. The first assignment is to do a waste observation for your QA processes. So I will explain in detail what you need to do, and while you are doing, also we will be there to help you if you have any questions. Then we will have a small break after point number 6. Then again, after the break, we will be doing another activity. We'll be understanding the difference between error versus defect. It's a discussion. The point number 8 is fundamentals of manufacturing. Basically, the it can be service as well. The whole supply chain mechanism, and then another activity, a method error proofing activity. Then point number 10, what is quality, cost of quality and cost of poor quality. So this is the plan today, and we'll be covering everything, and we'll be understanding all these assignments, activities, and if you have any questions, stop me during the time, and we will be happy to answer any of the questions. So we'll first move to our activity. Darshana will take over the screen. Darshana?
Yeah, okay. So thank you. I will share the.
Right. So the activity which we have done, we will be conducting same kind of activities throughout the sessions. So you can refresh your mind, refresh your learnings, and then move forward. So I will reflect what we have learned last week. So we have given you how this program works, the administrative part. So we have covered that part, and then we have learned what is quality is about. So we defined a definition also for that. Everything what all the participants said are right. There's no any wrong answer, but if you want to stand out from the rest, so you can use that formula, which is what already there in the Kahoot game as well. Quality is equals to performance divided by expectation, and there were actually 3 scenarios where you can define quality based on the results that you're achieving. Then we have learned about the QA history from Giza pyramid to current today's philosophies. So we learn about few important names who are involved in invent some of the philosophies and some of the concepts. So in that history, we have talked about Frederick Taylor, the Taylor system, and also Walter Shewhart. Then the Edward Deming, the father of quality, and also Joseph Juran, and then how they have connected with Toyota. So the history talked about how USA and Japan worked hand in hand after the World War II to evolve this manufacturing. So we talked about those two people, and also Kaoru Ishikawa also. So those are the giants or pioneers in quality. And then we talked about lean history as well, how Toyota came into the picture with their loom business. And then the Henry Ford, how this lean word came into the world, and then how this the book The Machine That Changed the World, once they have released this book, people got to know about this lean word, and then we talked about that as well. And then so we talked about the definition of lean. I will just highlight and summarize what is the lean definition is all about. You just need to remember only these key points, key words, and then you can use the connecting words to make this definition correct. So the lean is all about, it's a systematic approach, and then there's another word called waste elimination, and then continuous improvement, and it is throughout throughout these continuous improvement activities, we are trying to make best product, best quality, with lowest cost, and then with a shorter lead time. So the definition is lean is a systematic approach to identifying and eliminating waste or non-value added activities. Non-value added activities are also waste. If you don't get any values, you are not achieving anything that is not directly impacting your productivity. So that is also a waste. Identifying and eliminating waste or non-value added activities through continuous improvements, which means kaizens. We will learn about these jargons in future sessions as well. Kaizen is about continuous improvement. We will learn more about Kaizen in future classes. By delivering services or making products on time with the best quality and the lowest cost. So that is the definition of lean. Then we talked about eight wastes. So you can remember it very easily using this Tim Wood acronym. Tim Wood, you can refer, T is for transportation, I is for inventory, M is for what do you call it? I can't even remember. Darshana, what is M stands for? I lost my memory. Okay, I will share it. You can refer to the handout as well.
Movement, right?
Sorry?
Is it movement?
Oh, no movement. It's not coming out. Okay. So I will share the Timwood abbreviation as well. So we talked about 8 wastes, and then the lean house and Jidoka pillar. So those are the things that we have learned last week. You can refer to your handouts and also the recording to understand in detail what we have learned, and we'll move forward. So with this, we'll be starting today's module. So we'll understand this quality control, quality assurance, quality engineering, quality management system philosophies separately. So I'll be discussing these 4 philosophies with first I will share the focus of each of these philosophies. The first one is quality control. Since you were in manufacturing, you both are in manufacturing, these jargons, and if you have any doubts, stop me. You can, unmute yourself and ask questions, or you can, type, your question in the chat box. If not, I will continue. So the quality control focus is to identifying defects, right? So I have highlighted the key words in bold highlights, so that you can you have a better clarity on that. The focus of quality control is to identifying defects in products or service through inspection and testing, right? That is basically to identify defects. That's it. That is what quality control means. Quality assurance focus is process of quality improvement and ensuring that processes are designed and implemented correctly. So the key thing is ensuring that processes are designed. In quality assurance, you are designing your process so that people are following, if people are there, if machines are there, you are, following that process in order to achieve your quality. So the focus is to design the process in which way you get the right quality. So that is what quality assurance is all about. Quality engineering focus is to, design and develop, focus on the design and development phases of the product or service. So in quality engineering, you are not talking about your bulk manufacturing. We are talking about the design and development stage. So before we, do any manufacturing, we have to, do, basically the prerequisites of the manufacturing, the bulk manufacturing. So you have to do, your pre-production processes, your design, your proof of concepts, you name it. The design and development phases is the focus of quality engineering. And then to ensure quality is built into the product from the beginning. So you design the product in a way you get the right product output. So you are working more in your pre-production process. You are working hand in hand with your design team, your pre-production team, your customers, your marketing team. You work well in well in advance to incorporate your quality into the product or system. Then your manufacturing or your service, the bulk production, makes easy. So we will be discussing some of the techniques like design for manufacturability, DFM. DFM is all about, you design your product where your manufacturing gets easy, right? So sometimes you can, see when customers ask, some requirements. If you have a business as usual, a process that, currently running, if your customer is asking something different, sometimes you have to, go and convince your customer, okay, we will meet your requirement. We will, deliver what you're asking, the deliverables. But the process that we are doing is our way, right? Sometimes you can't do that. Some of the customers, they have the authority and also the control of your process. So for those customers, you can't do that. But when it comes to design for manufacturability, you are working more with your customer. So you design your products according to your manufacturing system. If not, you are working, well ahead, and you plan your manufacturing to deliver that requirement. So that is about quality engineering.
Quality engineering is activities root cause analysis, validation, design for quality.
Exactly. So in quality engineering, if like I said, since you're working, well ahead in your design and development stage, you're doing all these problem solving, root cause analysis. So if you talk about this quality engineering, now we will be talking about this problem solving. There's a separate session for that as well in this module. And so those, in that problem solving session, we are talking about two problem solving activities. There are, two scenarios only when it comes to problem solving. One is present problem solving, problems which are already happen or which are, already happening. And the other side is future problem solving. So when you talked about this quality engineering, we are talking about future problem solving. There's a separate session in our certified quality expert program to, understand one or two tools, how you do this future problem solving. So we are talking about FMEA. We are teaching you FMEA as well in our quality expert program. That is about root cause analysis, and you're identifying future problems, identifying potential problems in which can happen in future, and you make sure those are not going to happen. You make sure those things fix with the system, with the product, and then your manufacturing gets perfect. Abdul, yes, like you said, we're talking about quality root cause analysis as well in this quality engineering. So when it comes to quality management system, the focus is to formalize a system, right? Formalized system that documents processes, procedures, and responsibilities for achieving quality policies and objectives. So quality management system, this QMS, is all about achieving quality policies and objectives. So when you talked about quality policies and quality objectives, it's about connecting everything. Quality control, you have to do quality control sometimes. You are doing quality assurance, you're doing quality engineering, and you are achieving everything to everything to achieve your quality policy or your quality objective. Your quality policy can be different from from your company to company. So like I'll give you one example. One company that I work with, their quality policy is to achieve 100% FTT. That is basically their quality policy. It's simple as that. 100% FTT throughout. So throughout their manufacturing, from RM inspection to finished good loading. So if you talk about FTT, first time through, if you can achieve 100%, you are like a world-class business and world-class manufacturing. So that is the quality policy. So QMS comes under that. So that is basically the focus of these 4 philosophies. And also why we are learning all these philosophies, because our focus is to learn built-in quality, right? So that so all these are one side of quality, not lean. So we have to have this background knowledge in our fraternity, in our background knowledge, so that built-in, when you learn built-in quality, what is the difference, what are the things that we are trying to achieve through built-in quality. So that is why we are learning all these quality concepts. I hope you both are clear on this, and if not, like you can ask questions, or you share your ideas. So let's move into our activities. Let's understand what are the activities. Yes, Abdul, go ahead.
Yes, clear. Yes, clear.
Okay, thanks. So the activities, again, I have highlighted the things that we are doing, each of these philosophies. In quality control, the activities are product testing. We do test product, process monitoring, and inspection. So last week, you have learned about this SPC chart, statistical process control chart. The person who invented this concept. So process monitoring is comes under that. Process product testing is like your MIL standard, the AQL standard that you're following. So those are the things that we are doing under quality control. That is basically to identifying defects. That's it, nothing else. So if you talk about quality assurance, conducting audits and reviewing process, that is the difference. I'll read this whole sentence. Activities of the quality assurance is to creating and implementing quality standards and procedures, conducting audits and reviewing processes. So you are reviewing the process, you are auditing the process before you start the production, and make sure your processes are correct. Then only, like we said, the focus, you are ensuring that process are designed first, the focus, and then you are auditing that process, whether the process is functioning right or wrong. So if the process is functioning correctly, you're achieving the right quality. If the process is not there, you will not achieve the quality. So that is about quality assurance, the activities. So you're basically conducting and monitoring. You are make sure your process is there. And when it comes to quality engineering, you are doing design reviews, risk assessments, statistical analysis, and there are reliability testings as well. There may be hypothesis testing, proof of concepts. You develop POCs, proof of concepts, and you do some trial runs. Those are quality engineering. Like Abdul said, risk assessment. One of the risk assessment I explained, FMEA, failure mode defect analysis, is a future problem solving tool. So we do design reviews, and then we assess the risk, and then we make sure those risks are mitigated, and then we try to understand how the data behaves based on the testings that we have done. And those are the activities that we do in this quality engineering. When it comes to quality management system, the activities are like, we have to document everything, the processes, quality procedures, everything. And then you inspire your team. There's a team always, right? When we talked about the lean house last week, the middle of the house, there's a motivated team. So this team has to follow this documented process, and they are in their blood. They are they have to follow all these quality policy. If you set a quality policy, the contribution of each and every individuals has to be 100% equal. It can be a janitor, a cleaning person, can be your general manager, a director, or an executive supervisor or team member. They have to follow these procedures. So the activities in this quality management system is to make sure you document everything and you inspire your team through this documented process you have made. So those are the activities that we do in these separate philosophies. And I will move forward to understand the goal of each of these philosophies. The first one, quality control. The goal is to identify and correct defects before products are delivered to customer. So the main objective, the goal, is to stop the defect before you pass it to the customer. Simple as that. So you identify defects, you do testing, audits. How you do that? You do testings, process monitoring, and inspection, and you segregate the non-conformities, the defects, and you deliver only the good products. That is the quality control objective. Quality assurance objective or goal is to prevent defects. If you do quality assurance, your objective, your goal is to prevent defects, prevent happening the defects, and then you implement, like we discussed, you set the processes and you monitor the process. How you achieve this goal, prevent defects from occurring by implementing processes. So that is the connectivity, right? The quality engineering optimize the product design and development process to minimize defects. So I talked about you work well in advance to make sure your design is correct, and you do change the manufacturing processes. You do design reviews, risk assessment to optimize the product design. You optimize your product design where you can manufacture your product easily. So you achieve your goal, right? So that is the goal of the quality engineering philosophy. Quality management system, you provide a framework for consistently producing and delivering products. So the whole quality management system is to provide a framework. You have a nicely documented process, a framework. In that framework, there can be quality assurance, there can be quality engineering activities, can be quality control activities as well. So the quality management system is the holistic approach, or the the main arm of this, philosophies, and these are the differences. So hope you can, understand the differences between each of these through the focus, activities, and goals. And also, I like to give you another small formula. So this quality assurance is equals to quality engineering and quality control. So if you have quality assurance, if you're following quality assurance, you should have quality engineering practices and also quality control practices. So that's why I said quality assurance is equal to quality engineering plus quality control. And if you are following quality management system, you should have quality engineering practices, quality assurance practices, and quality control practices. So the formula for that is quality management system is equal to quality control plus quality assurance plus quality engineering. So that is basically to understand how this philosophies works, right? So this is just an understanding about these philosophies and how it works. Yes, I mean, go ahead.
Yeah, so you were explaining regarding quality control, right? So, and we were talking about quality assurance. So, quality assurance is preventing defects, right? So, if I go to a line, you'd have a CCP, right? A CCP is a thing that would prevent a defect or a hazard. So, is that considered a quality assurance step or checking the CCP? And so it's a prevention that is done, right? So we check a CCP during the line. So it's a quality control check. So how does it, like, which area does it satisfy? Is it the quality control or is it a quality assurance inspection?
Oh, I have, what does the CCP stands for me?
Critical control point.
Oh,
As in
critical, okay.
HACCP. Yeah.
All right. So critical control point is under quality assurance, right?
Right.
Because it can be, apparel manufacturing, it can be food manufacturing. When it comes to the good manufacturing practices, you have these critical control points. So critical control points are, basically quality assurance. Any manufacturing, you have critical control points. So let's say I'd like to give you an example. So metal detection, right? So metal detection is a critical control point, but you are detecting it, right? It's a quality control part, but you're setting this process, right?
Right.
Setting this process, so that comes under quality assurance. I will give you another example. So metal detection is a critical control point, and you may have heard this abbreviation MD and MCP. MD is metal detection, MCP stands for metal contamination prevention. So metal contamination prevention, let's say you are in a manufacturing and your team members are coming up with all these jewelries with all metal pieces, free metal pieces, but you can't have those things in your manufacturing. So that is, if you talk about that, you're talking about metal contamination prevention. And let's say you are not using staplers in your manufacturing, you are using only tapes. So that is metal contamination prevention. But if you don't have metal detection, you don't have an assurance. So you have to have metal contamination prevention as a quality assurance and metal detection also as a quality assurance part. Again, metal detection comes under quality controls as well. So that's why I explained quality assurance is a combination of quality engineering and quality control. So that's a good question. That's a great example to understand the differences. Your CCP can can satisfy quality control and quality assurance both.
Right.
Hope the examples are clear.
Thank you. Understood. Thanks a lot.
Super. All right. So we'll move into this is the highlight of what we have learned. Quality control deals with detecting defects in product. Quality assurance ensure processes are designed and implemented correctly. We are talking about processes here. Quality engineering focuses on optimizing product design. We're talking about product design in quality engineering. and in QMS, the whole framework to, manage the quality across the organization. So that's what we have, talked about a little while ago. Moving on to stages of inspection. So this is also, like I said, we have now talked about quality control engineering, assurance, and quality management system. The stages of inspection also, we have to understand these things before we learn the built-in quality. That's why we are learning some of the, concepts. So we'll understand these three inspection stages separately. The judgment inspection. The first one is judgment inspection, which is to assess the quality of output or sort output defects from the outputs. So judgment means you judge the product, judge the output, judge the can be semi-good, and then you sort it out, defects or goods. So that is judgment. So when you learn built-in quality, when you move forward to our next sessions, you will learn the connection between the things that we have learned. In built-in quality, we will be talking about 5 phases. In those 5 phases, the whole backbone of this built-in quality, there's a thing called judgment inspection. So when you go to that 5 phases built-in quality philosophy learning, you will get to know that this is why we have learned this judgment inspection. So judgment inspection is like quality control, right? Informative inspection is another inspection stage. Assess the process by inspecting output. So here we talked about process by inspecting output and using information gain to control the process. So you do the process inspection, and then you give feedback to your previous process. There's a feedback loop. So you do a process audit, and if you find anything wrong, if you see something not working properly, the process activities, you feedback it to the previous process. You first correct that step, and you feedback it to the previous process, and then make it correct before you go to the next step. Abdul, go ahead.
Yes. Can we say inspection, inspection in self judgment inspection?
Say it again, please. Incoming inspection.
Incoming inspection says to judgment inspection.
Yeah. So let's say if we do manufacturing, I will be talking about the basics of the supply chain as well. In supply chain, the whole supply chain works source, make, deliver. So source is incoming, right? Your input. So your input you have to inspect. There's an if you don't have a process, it's okay. If you do inspection, that's based on the requirement. And if you can survive without inspection, that is perfectly fine. That is what we need. So incoming inspection comes under this judgment inspection. That I think that's what you want to ask, right? Is that or is it something else?
Okay, sir.
Okay,
I understand.
okay, thanks. So informative inspection, we talked about feedback loop. So you inspect, you assess the process, and if you find anything wrong, you feedback it to the previous process and make it correct before you go to the next step. So that is comes under quality assurance and quality engineering. When you do quality assurance and quality engineering, you do informative inspections, not judgment inspection. And then the source inspection. Assess beforehand whether the condition necessary for high quality production exists. So this source inspection, let's say you both are in is in tea bag manufacturing. So you get a mesh fabric. So let's say you are inspecting your mesh fabric once it in house, and you find something wrong, you have to reject the whole lot, the fabric lot, right? And it can happen to Abdul as well. But if you can make sure your input material can be, your raw material can be fabric or other accessories, if you can make sure your materials, the raw materials for the next operation, okay, for the next operation, I'm highlighting this again, I'm emphasizing this again, for the next operation, your raw material can be your the fabric or the accessories, and also your next operations semi goods. So if you can make sure your raw materials or your semi goods for the next operations are perfectly fine to proceed or continue, that is source inspection. So you make sure your products, your raw materials are 100% complying to make the next operation, to proceed to the next operation. So that is about quality management system. So in this source inspection, you have quality engineering. You work well in hand. You work hand in hand with your suppliers as well. You make sure your supplier comply with your requirement. So you're not make a boundary. So you go work with your supplier and then make sure your fabric, your accessories, your raw materials are correct. So that is source inspection. You make sure the processes are there to get the right product, right raw material. Yes, Abdul, are you trying to
Source
say something?
inspection, it means final inspection.
No, not the final inspection. Good that you have asked that. So final inspection is your last inspection before you ship the product. You do a final audit, or it can be audit or assessment or an inspection. Sometimes it can be inspection, like 100% inspection. Sometimes audit. So most of the time we do audit, right, based on the AQL. We will learn those as well. So we learned about AQL standard as well last week. Final inspection is happen before you send the shipment to the distribution center or to your direct customer or your consumer. Based on the business that you do, it can be different. Source inspection is like you work with your suppliers. You work with your before process. Let's say you have I have given this fabric example. You work with your fabric supplier and then you make sure your product is right, your process is right. And then let's say you have two different businesses where you do one part under the same company. There's another factory, there's another business, there's the other part, the supply part. So source inspection means the supply part has to be comply with your manufacturing. So you work with your sister factory, sister plant, sister company. So the source inspection is always beforehand, and we make sure materials, semi goods are there with the right process, with the right the product. So that is source inspection. Abdul, are you clear on that?
Yes, are you okay?
Okay, thanks. So these are the stages of inspection. We just need to understand these as I'm explaining again, just to have it in our mind before we go to the next sessions. Moving forward to our first assignment. So this is waste observation. We learned about waste last week, and what you need to do is, I will explain with an example what you need to do with this assignment. So you have to submit your assignment before next week class. You can submit it to the same WhatsApp group, and then if you during the time when you're doing your assignment, you can ask any question if you if you happen to find any ambiguities with this assignment. And I will explain what is this assignment is all about with an example. So we will, once we finish the class, we will be sharing an Excel. You can fill that Excel, or else you can take a printout, or you can use it as a hard copy and scan it and send it, or you can use the same Excel format, fill it and then revert it to us. So the waste observation, I hope you can clear this clearly visible. There are few columns. I will explain each of these columns with the example. So the first one is the observation, the waste. So when you're doing this assignment, you try to do it in your own department or your sister department. But when you're doing it with your sister department or in your department, make sure you go ahead, go with the functional owner, the process owner. Let's say you are a quality manager. You go, if you're auditing, if you're observing your process, one module or one product or one department, you get that you get your supervisor or executive or whoever who's on that process, and take him or her with you to do this assignment, so that you have a action implementation as well, and then you can improve your process as well. So this waste, the observation is the example that we have given. I have given two examples. One is in manufacturing and the other one is in day-to-day service activity. So the example is quality checker or quality auditor travel to method study or quality assurance department to get measurement sheet. So even in tea bag manufacturing or this apparel manufacturing, we have method study team or quality assurance department to get the measurement sheet. So the quality checker visit can be style wise, or it can be day-to-day basis. You go and visit, get the measurement sheet, and come to your quality checking table, and then you start checking the product. So the waste type is motion. Okay, I got this the M, the one which I lost. The Tim Wood, the M is motion, right? The waste type is motion. So why this waste type is motion? Can if you both can answer. If Amin have sometimes you may have referred the video. Why this waste? Why this observation is a motion waste? Why not a transportation waste?
Here it's talking about the auditor. He's traveling, right? So he's moving from one department to the, like he has to go from the department to get the measurements. So he's moving. So
Yes.
it's a matter of his time and his movement. There is no additional transportation discussed here. It's not talking about he's using a truck or he's not using any sort of transportation mode. It says that he is moving. So when it comes to once we further specify, if we specify the observation properly, he moves from one location to the other through a mode of transport, then in that context you use the transport as well. But in case he is not using a transportation, which is being mentioned based on the statement on this, so I would use it as a motion of that individual.
Sure, thanks. Okay, Abdul, do you have anything to add? Are you okay with that answer?
No.
Okay, thanks. So I mean, thanks for that. So I need to clarify one thing. I like your first part. So why this is a motion waste is because we are talking about a person, right? A quality checker or quality auditor. Why it is not a transportation? It's not because the mode of transportation, because here a person is traveling, right? A person is walking to the method study or quality assurance department. It's not because of that. Transportation, we are talking about material transportation. If materials are moving, there's a transportation waste. If person or a human is moving, we have to consider it as a motion, right? Why this is a waste? Because every day, let's say, let's imagine this person the quality checker, every day he or she has to, go to this method lab or quality department to get this measurement sheet. So it's a waste. The person is moving every day. The person is there to check the product. That's the task, right, that we have assigned to this person. That is why we are paying for them. But this person is traveling. It's a motion. That is why it's a waste. First thing is that. And why not a transportation? We are here we are talking about a person. A waste regarding a person, waste regarding a human, not regarding the material. So if you talk about material moving, material movement, unnecessary movement of material, we have to consider transportation. That's how the difference between motion and transportation. It's okay. So now we know why this waste type is a motion. But I like the interpretation. So let's move into our the other columns. So the impact, we have to understand the impact as well. So all these letters are, you can understand it as, you can write it down, or there's an abbreviation sheet as well, abbreviation slide as well, where you learn all these jargons throughout these sessions. SQDCM, we call it as SQDCM. Why these SQDCMs are, call it as impact? SE stands for safety, Q stands for quality, D for delivery, C for cost, M for morale. So all these things are related to the business financials, right? The P&Ls. So safety is directly directly or indirectly impacting quality, obviously, delivery, obviously, cost, it's there's a definite connection, morale of the team. So the impact of this waste, you can I have highlighted this as quality impact, delivery impact, and then morale impact. I haven't considered it as a safety. A person knows how to travel to quality department, so there's no any safety issue. If there is any confined space or something on the floor which can make an harm, there's a safety issue. But we should not think on that angle. So the quality is because this is purely, we are talking about the person task. So this person task is to check the product. So the quality is, why the quality is ticked, because this person is traveling to get the product, the measurement sheet. So the quality is compromised. That's why the quality is ticked. The delivery, obviously, so you are delaying your deliveries. That's why the delivery is ticked. Morale, obviously, every day he or she has to move. So it's a annoying thing for a person to go and ask the measurement sheet. If the person is not there, if the computer or the printer is not working properly, they will get disturbed. They will get unsatisfied. So that is why the M is ticked, the morale is ticked. I think you can think on that angle when you do your waste observation. And if you have any concern, just stop me and ask, right? I hope that is clear. And the relevance. So relevance, we have considered the 4M and environment: man, machine, method, material, and environment. 4M and E. So here man is ticked. Obviously, a person is moving. There's no any relationship between machine. If if we think a printer is not working, yes, you can consider. But the waste is purely talking about a movement, a motion. So not talking about any machine or any other thing. Method, yes, the method, there's a method defined to get the measurement sheet. So the method, that's the process, set process. Material, no issue. If the waste observation is talking about A4 papers, or printer is damaged, or the poor quality of papers, yes, you have to tick material. Environment, if the environment is not suitable, the lighting is not suitable, the walking pathways are not, you know, cleared, you have to tick the environment. And also if you have to consider the other angle, the sustainability angle, yes, you can tick that. Why this person is printing so much of papers? You know, let's say you need only 1 copy, but this person is printing 5 copies. It's an environmental effect, sustainability issue. So you have to tick that. But here we have ticked only the method part. The method is set to go and get the measurement sheet from QA or method study department. So that is how this impact and relevance work. The countermeasures are the corrective actions. There are 2 countermeasures. First one is immediate action, fix the obvious. You see something and you fix it on, you know, on the spot, you know, then and there. So those are, you know, see the obvious, fix the obvious things. You see it and you fix it. That is what we need, you know, always in manufacturing or service. So the immediate action is to arrange measurement sheet along with the style handover meeting. You know, it can be arranged with the style file when team members are taking the style file. So you have the measurement, you have all the measurement sheets. You don't need to worry getting printed it out every day. So it's only a one-time movement. So there's a no waste once you do that. So that is what I have, you know, given. It's, you know, a simple thing. So the long-term action is, that is about standardization. Arrange measurement sheet into shop floor data system. Imagine you have a, you know, data entering system in your shop floor, in your manufacturing facility, production floor, and you are, you know, embedded your measurement system with the styles to your shop floor, so that, you know, team members, you know, once they come early morning or when they start their shift, they, you know, search the style or the measurement sheet, start, you know, inputting all the data. So that is about a long-term action. So it can be, you know, there may be some processes, you know, you have to do before that if you are doing, you know, it in manual way. And you know, it can be, you know, long-term process as well. So that is what I have given. This is my example. You can think on, you know, some other actions as well. So the responsibilities is assigned to quality QAGL, quality group leader. This is purely, this responsibility is only for the immediate action, not for the long-term action. This responsibility comes under the see the obvious and fix the obvious thing. And there's a, you know, deadline as well. Once, you know, you take these long-term actions, you know, it's a management thing. You know, some of these, you know, actions you can't, you know, implement it in a one production module or production line, or, you know, one, if you have multiple departments where you do this same process, you can't implement it in one department. You have to implement it in, you know, across your departments. Or, you know, you have multiple SBUs with sub-business units, you have to standardize across your company. So those are, you know, management things where you can, you know, consider those under your management meeting and then make an action plan. It can be, you know, 1 year or 2 year, you comes under your 5-year strategies as well. So that is the example. That is the waste observation, you know, process. So why I have explained everything, you know, in detail, and also why I ask you to, you know, do it in your department, so that you can see your waste and you can get some gaining once you know, fix those obvious waste, obvious errors. I hope this clear. If not, you can, you know, ask questions now. Once we move forward, you will get the assignment, and then superb. Thanks. Abdul, you clear?
Yes, clear.
Super.
I try best is example fill.
Okay. So the assignment is to fill 5 observations. Find 5 observations. When you go to your department or shop floor, you will
5 observations.
5 observations. It's so simple. You will see enough problems, enough waste. Right? We got like 10, 12. We asked only 5 assignments in our last 4 batches, but we got about 10, 7s, 12. And you don't need to complete all these tasks, right? If you can complete all these tasks, if you can assign all these tasks to your team, you also get the benefit of that. But you just observe this and understand the waste type, impact, relevance, and also come up with a action plan, short term and long term. So you don't need to share how you have fixed it, how you have achieved the results. No need to worry about that. Don't bother about that. Just come up with 5 ways, and then we just need to understand how you have learn this waste observation, because identifying waste is the first thing that you need to do when you talked about lean and also built-in quality. So this is the foundation. And then the other example is excess concrete in residential project. Imagine you are doing a concrete slab, or you're doing a 2-story building or house. You have to do this concrete mixture, right? So the waste type is, I have given overproduction. Let's say we need 50 cement bags. Imagine that's an example, 50 cement bags, but you have make 60 cement bags, because when you do a concrete, when you do a a 2-story building, your slab, you have to you can't do it on the go. So you have to make it prepare well it advance. So imagine you made 10 extra. That is why I have given it as overproduction. And also there's a over processing waste as well. But the obvious thing is overproduction. I have considered the impact as cost. There are moral impacts as well, but I just considered cost. You can consider anything, but it's up to you to decide based on your observation. And the relevance, imagine your manpower utilized, machines are utilized, method, material, environment, polluted, everything is there. So the relevance is for all these 4M and E. Measure, and the short-term action is to measure and calculate exact concrete requirement, rather go for a gut feeling decision. So when you go for your village concrete person, they will in their gut feel, they will say, okay, for this we need 60 cement bags. That's how you get the number, right? For that, what I have given is to do a calculation, measure and calculate what is the exact requirement. So then you won't waste anything. And then for the long-term action, I have given it as define a calculation method and standardize. So if you know your thickness of the concrete, it can be 10 inches, can be 6 inches, 1 feet, 1 foot thickness. And then if you know the square feet, and you can understand the capacity, the requirement, the cement bag. So you define a calculation method as a small formula. And then if you get a 2-story building, like 1,000 square feet slab, or it can be 1,500, 3,000, the exact quantity. So that is the long-term action. I have given it to project management, and next project onwards you can implement it, right? So this is a service sector day-to-day example. You can think on that as well. But when you do the assignment, go to your production flow and identify 5 waste, and you can do it simply. And if you delay to submit your assignments, you will get 20% marks deduction. That's no excuse on that. You can do it easily. There's no issue asking any question when you do it. If you do only 3, you will not get, marks deduction. That's okay, but try to do 5. If you can do 7, 8, that's even better for your business. You can, implement everything, right? So, but delays are not acceptable. So you will get 20% marks deduction. So that's the first assignment. And before we move into our next, yes, Amin, go ahead.
When is the, sorry, I couldn't follow. When is the due date as such?
Before the next class.
Okay.
So next Saturday, 8 p.m. Before 8
Sure.
p.m. Yeah.
Sure. Okay. Thank you.
No worries. You're welcome. So we will have a small break, 5 minutes break. I don't know what the time is now. I think it's 10:55, right? So we'll come by 11. Oh, is it? Sorry, 8:55, right? Sorry. So we'll take 5 minutes break. And if you have anything to ask during the break, also I'm here. You can ask any questions. We'll stop now for a small break, and we'll come back by 5 minutes. Thank you.
Error is defect is defect is a major problem. Error is proof non-mistake and error.
Good try. Thanks, Abdul. Yeah. We'll see how Amin's answer is also. I mean, you need more time, or what do you think?
Yeah. So defect is a thing like, probably it can be a result of an error.
Mm-hmm.
All right. It can be a result of an error.
Okay.
Whereas an error is concerned, it can be action that has led to a mistake.
Okay.
All right. So,
Super.
and at the same time, like, when you look at an error might be, it is most probably reversible. It can be corrected.
Mm-hmm.
But once a defect occurs,
Mm-hmm.
to correct the defect, it's difficult. So error, you can correct it reaction wise, but a defect, when it comes, you need to do a rework, or you need to go like, you have to do a total cycle of, again, to actually make it defect free.
Okay.
That's what I.
Okay, super. So you're spot on. A perfect answer. So thank you for that. And also your interpretation on how you see the defect once a defect make, how how we need to rectify it. So error, yes, as you said. I will show this picture as well. So in this picture also there's a boy, right? Or there's a girl who has loosened his lace in this first picture. I will take the laser point. So the lace is loosened, and then the next picture, the girl is it's she's about to fell down. So like you said, error, defect is a result. So the result is this girl is falling down. Why? Because she has a loosened lace, and it entangled her the other leg, and then she falls down. So like you said, error is a cause, right? Error is an activity which can lead to a defect. So this is a cause. Error is a cause which result a defect. So basically this is like cause and effect, right? So the error is a cause which can, happen a defect. Like you said, we can, rework the defect, but there's a process for that. There's a time for that. But when it comes to error, you can fix that well in advance. But defect, you can't. You can by doing a rework. There's a process, there's a cost involved on that. But if you see the error, if you can, fix it when it, happens in error stage, there's, the cost may be, minimum. You can reduce the cost. So this is why, we want to, learn, because the difference between error versus defect. And now you have a clear, understanding what is the difference. Move to the next slide as well. So I'm again, saying why we are learning everything is to, connect everything, connect, all these dots to, understand the lean and also the built-in quality, the lean quality. So the definition for error and defects is clear, and this is the definition for built-in quality. So I'm going to ask another question. What do you think? What are the things which are not passed on to the customers? Here, if you think here, what do we, what should not pass on to the customers? What should we, control? What should we not pass on to the customers? If you are doing a business, if you have a customer, now we know about error and the difference between error and defect. So if you, think on that angle, what should we not pass to our customers? Defects or errors? You can try, there's no any, when you are learning, don't think, your answer is wrong. That's why we are learning, right? So you can learn everything if you, if you make mistakes also, you learn something. So what should we not pass, errors or defects?
The fact should not pass to the customer.
Super. So we should not pass defects to the customers. If we pass defects to the customers, we are gone, right? If customer, finds any defects, we may have, repercussions. We may get, claims, fines, and, there are, many things can happen. So, what should we detect, control, and prevent? We should errors, right? We should detect, control, and prevent errors. So the built-in quality definition is, it's a system to enable a process to detect, control, and prevent errors. Hence, defects are not passed on to the customers. So that's a definition. And that's why we have, learned this error versus defects, the difference between error versus defects. And also we have learned the waste observation also. You will learn, you will, understand what is the connection between the waste also when it, when we move forward to our next classes. Moving forward, and I think you can, fill your handouts also if you have a printout. Try, getting printouts if you don't have it now, next class onwards also. And you can write the things that we are, learning. So this is the definition of built-in quality. And so I'm giving you, some of the everyday examples. So this is VGA port. So we know we now know errors and defects. So VGA port is, the port that we are connecting a computer with, your multimedia project or anything. Can be your television or anything. So in VGA port, you may have seen the same port design, right? The shape. So no one can, plug it, the other way around. It has to be perfectly aligned. If not, you can't, put it inside. So that's a error prevention, right? That error prevention, because of that error prevention, you will not get, any defects. You will, not, find any difficulties of, putting this together. So that's a error prevention. That's an everyday example. And also, if you, this example, the fuel cap. So, early days you have, you don't, you haven't seen this, there's a string attached to the fuel cap. And now you have that. Before, this comes into the world, there's only, there were vehicles with only the fuel cap, no strings attached to it. Once you, open the fuel cap, once you, keep it aside, once you, do fuel your vehicle, you may forget the fuel cap. Now you have a string. And even now, the modern vehicle, like after 2022, you don't have this fuel cap. You have a, automated, not an automated, it's a mechanically, arranged gauge, a cap inside the fuel tank. So you insert the fuel nozzle and it opens. And once you take out the fuel nozzle, it closes. So you don't have, fuel caps anymore in your, in today's cars, like after 2022, I would say. So there are things, which, improved by these automobile manufacturers as well. That's another error prevention. And also, this is a super, classic example when you happen to, get money through a teller machine. Sometimes early days, there were no chips attached to the ATM cards. So you may have, mistakenly input your ATM card in the wrong direction. So you have to, wait 1 or 2 days to open the bank and go to the bank and then ask the card. Now you have a chip card attached to it. And even after that, there's a direction of, inputting the ATM card. And also, again, there's another improvement which they have made. Early days, you have to, take the money out first and then take your card, ATM card, right? Then what happened? You have, forgotten your ATM card in the machine. You take only the money, right? That's what your, main objective is to, go to an ATM machine, get the money, run faster. Then you, forget your ATM card. Now what happens is they have improved it to the next level. You get the card first. The window says, the panel says, you get your ATM card first. Then then we will, give you the money. Then the teller machine give you the money. So obviously you take the card and then your first thing is to go and take the money. So you obviously, wait to get the money. So that's how they have improved the system. These are everyday examples, that you need to, know. And there's another service related example as well. I will, run through these examples faster. So this is a pizza delivery shop, pizza shop. So the error, in early days, you had to call the pizza shop and, make your order. So when you, call and give them your order, they have to write it down there, the address and everything, the order detail. So what happens there, when they write down the orders, your address may get wrong. Your pizza flavor can be, different. They may be, mistakenly write down a different flavor or a, quantity. So that's the error. They enter the wrong address code. And the defect is the wrong delivery location. This is a service related example. We just, need to highlight some of the things, you can see in service sectors as well. So the defect is wrong delivery. You won't be able to, eat your pizza. You are in, you may be in hungry. And now you see, you have to, there are apps. You just need to input your flavors, quantity, address, everything. And there's a confirmation messages as well. so that your address is input correctly, and you have your correct flavors quantity as well. So that's another example. And these are some of the manufacturing related examples. There's a patchy dyeing issue in this denim skirt. The defect is dye patch in the fabric. Once the dyeing process happens, you see the dye patch, and then the error is dye particles are not being mixed properly. If your dye particles are mixed properly, you won't get this defect. So that's the error and the defect. And then the other one is loose or tight stitching. So you see there are perfect stitches, and also in your right hand side 2 loose stitches, and the left hand side there's a puckering stitch, too tight tension. So the error is improper thread tension. If you don't have the correct thread tension, that is an error. You get this loose stitch or tight stitch. That's another example. And this is another day-to-day example. Paint bubbles appears during summer or winter. In your door panels, in your windows, paint bubbles can appear, right? Bubble particles. So the defect is that the error can be because of this improper paint mixing, dirt contamination. If you contaminate dirt particles, foreign materials into your ink, you may see this happen when the climate change. Even it can appeared soon after you done the painting, but there's a thing you can see after a while. So this is another example. And so another concept that you need to learn here, I think so far you are okay, right? We just understand the built-in quality and some of the examples in day-to-day practices. So this is another thing that you need to learn before we go into BIQ 5 levels. So in next future classes, you will be learning these 5 phases, and the impact of passing defects is because why we need to learn this, to understand the concept behind the built-in quality. And what happens when the defects, now you know about the defects, what happens if the defects are passed to the next operation, if defects are passed to the next customer, and each stages. So we now know about the errors and defects. Now imagine this is a cornflake or cereal like food manufacturing facility. You have the supplier, this is your manufacturing facility, and you are shipping your products through sea freight or air freight. So the whole concept of this manufacturing or service is, the supply chain mechanism is to source, make, deliver. This is the fundamental of manufacturing, the everything. You source any material, like the material that you need, you make something and you deliver it. You can say input, process, and output as well. So the basic concept. So your materials are moving to this direction, from supplier to your finished good department or your shipping department. And the information can move to both directions. You share information with your customer, you share information with your suppliers. The next operation, your previous operation or department can move to both directions. And if you find any defects, you get returns. If you find any defects at the customer end, you get returns, you get claims, you get big you have to name those products as B grade products. You have to face too many repercussions. So you get returns from next department, the within the facility also. If you find any defects in here, you have to return it to the previous operation. So there's another return as well. So what happens now, we learn about error versus defects. So if you find returns at customer end, I said some of the returns are like, you have to pay more claims, you have to pay fine for that, so you have to pay more money. And if you, find any defects within your facility, you don't have to pay that much of money like the way how you pay or your customer finds defects at their end. So less money here, right? You can rework it before it goes to the customer and then send the shipment back. And if you find anything at your supply end or your previous, pre-production stages, your material stage, you sometimes you don't have to pay anything. You can, if you are vertically integrated, yes, there's a cost. If your suppliers are nominated by your customers, if the error or the defect happens at their end and the fault is at their end, you don't have to pay anything. They have to bear the cost. So, you don't have to pay any money for that. So that is how this money cycle works. The return works if you pass any defects to the next customer. So this is also, a thing that we need to keep it in our mind when we, as I said, move to our BIQ 5 phases. So any concern or questions or any idea, Abdul and Amin?
No, it's okay.
Clear? Okay. I mean, I think you're clear on this. I will move forward. If not, just stop and ask questions. Okay. So I'm going to skip this part, and we'll be covering these parts in next classes. And this cost of quality and cost of poor quality, I'll be explaining what is this cost of quality and cost of poor quality is. So cost of quality, we have two elements. This is also another subject matter that we need to keep it in our mind. So cost of quality has two elements basically, which is cost of good quality and cost of poor quality. So cost of basically two things, good and bad. Cost of quality has good quality cost, poor quality cost. So cost of good quality contains prevention cost and appraisal cost. So prevention costs, what are these prevention costs? I will give you some example. So things like trainings for your QA team, your production teams, or quality audits goes under this prevention cost, because you have to, we talked about this quality assurance and quality engineering. So we have to, educate your team. You have to do audits. You have to make sure your system works, processes are works. So those cost goes under prevention cost. That is good thing. It's not a bad thing. And the appraisal cost. Appraisal cost, some of the example are testings and machine calibrations and your team salary. So we talked about metal detection. So metal detection machine, you have to calibrate it. It can be biannual, it can be annual basis. You have to calibrate it, right? So that's a cost involved. So it's a appraisal cost. It's a good thing. You have to, you're preventing it. You are budgeting it in your cost of good quality. And then your testings can be your production testing, pre-production testing, or final shipment testings. And your team's salary also goes under this appraisal cost. So this is good. That's why it called cost of good quality. And on the other hand, the flip side of it is cost of poor quality. So what are the things, which falls under cost of poor quality? The first one is internal failures. The second is external failures. I will give you some example for internal failures. So internal failures, we talked about correcting defects. Now we know about defects, right? So if you find defects, you have to rework it. If some defects can rework, yes, you can, but some of the defects you can't rework. Some of the occasions you have to reject those defects. You can't reuse it. So those are internal failure costs. Those costs are not good, not healthy for your business. Let's say if you have to do rework, you have to recheck the whole quantity. So to recheck, you don't have any assigned people for rechecks, right? You have to do OTs, overtime. Those are goes on the internal failures. And the recheck cost, I have, this is, a industry norm. So what it says is the rework time is equal to 3 times the process time. Let's say you are taking 1 minute or 1 hour to produce that product, or 1 minute to produce that product. If you happen to rework it, if the product is 1 minute, you have to take 3 minutes to rework that product, or 3 hours to rework that product. That is an industry norm or industry standard, to understand how big this rework cost is. So that is internal failures. And external costs are like returns, claims for complaint, and customer audit failures. We talked about the impact of passing a defect to the next operation. If anything goes wrong at customer end, if one shipment fails at customer end, you get returns. Sometimes you have to return the whole shipment, and then you may get fined for that. You have to pay extra charge for that. Those are external failures. So this is also another thing that we need to keep it in our mind when we move forward. That's why we learn this concept. And so if anything you have to ask, you can ask. And I hope this is clear, because if we are just covering only these this kind of a content in this CLQP program. But if you want to learn more about this cost of quality, cost of poor quality, there's another program in our faculty, which is TQM, another Canadian accredited program, TQM. It's again an online program. So you can learn more about this cost of quality and cost of poor quality if you join on that course. But for now, for this CLQP program, this is more than enough for our understanding. So next class, we will be learning these 5 phases of built-in quality, from phase 1 to phase 5. What are the things that we need to understand? What are the basics of this built-in quality, and connection between lean and quality. Now we talked about this lean house in our first class, and now we are going to learn this Jidoka pillar, built-in quality pillar. So basically we'll be learning this built-in quality 5 phases and the Jidoka pillar from next class onwards. So where you get to know more in-depth knowledge about lean and quality combination. So for today's class, this is it. And if you have anything to clarify, you can ask questions before we winding it up the session. And also, like I mentioned in the earlier, you can ask anything when you're doing the assignment, or if you see anything related to this content, or anything beyond this content, you can ask through our WhatsApp channel, and we are more than happy to help you. We are there to help you. Also, if you don't have anything to ask or any questions, would like to ask the feedback of both of you, the session, the content, and also the administration.
Yeah, so I guess there were a lot of things like which I actually some of them were refreshers. Same time, some things were new for me. Like those things I were not very clear about. I got those clarified, and also like the delivery was good, and I see like you all had used some what you call novel technologies in how to evaluate while the class is going. I really appreciate that. And sort of like I am really like they call motivated to actually do this program throughout and continue. So thanks for the great delivery, great work. Like keep it up.
Super, thanks. You're welcome. and you will learn more things.
Yeah. Everything is very good. I understand very well, and thank you.
Super. Thanks, Abdul. And if you see, if you happens to find anything to improve, before the next class, you can share with us, so that we are also continuously improving. Everything is for us to improve. We definitely will improve. Anything that helps participants and improve the course, and also the content and the learnings of your things, also the benefits that you gain in your business. So let us know anything if you happens to find. Okay, so we're going to stop the class for today. We will be meeting next class. Again, remember the assignment. I will be sharing the Excel sheet with you. Again, if you find anything, you can ask us. Yeah, Darshana.
Right. Okay. Thank you. So good. No, we will. Today we get the first assignment. Right. So first assignment. Thank you. Actually, from now we are slowly deep into the subject. So Jido, Kapila, and the BIQ. So today we discuss, and next week is the most important week for this class, because next week we are discussing about the 5 phase. Then Amin and Abdul, you can evaluate your company. Where are you now? According to the BIQ journey, whether you are in phase 1, 2, 3, or where you are, you can evaluate your company next week. That is the most important thing. Then let's say if your company falls into phase 2, from next another 6 days, 7 days, we will learn how you can bring your company into phase 3. Right. So the same way, next week, if you evaluate your company into phase 3, falls into phase 3, we will see how you need to take your company to phase 4, likewise, right? So that is why next week is the heart of this session, this class. Right, Chandra?
Yes.
Yeah, it's
True.
because of the BIQ 5 phases. Right. Okay, so that's small head-ons to the next class. We will meet and on next Saturday, same time. Thank you
Yes.
and good night. All.
Thank
Thank you,
you.
team. Good night.
Good night.
All the best.
Good night. Okay, thank you.